and then later moved into the medical equipment field. That led him back to Western Pennsylvania, and he's been back in this area and in Grove City for 27 years. And you didn't even know he was on your street.
No, I don't.
But she moved back, in all honesty, she moved back from South Carolina just 5 years ago. So we'll give her, let her off the hook. Now, after he moved back to Grove City, he had an opportunity, it says, to work actually on the railroad, and that's what helped for him to learn firsthand what the railroading industry was like, and that's where his further interest developed, correct?
Yes.
It just took off from there. And this evening he's going to share a little bit about that experience and what he has learned over the years. So I'll turn this program over to
Thank you.
Vinson Skibo. And by the way, welcome his wife, Renee. This is Renee over here. And you may have some other friends here that you would like to introduce.
Well, sure. Mike Schley, Mike's a Grove City resident, former Cooper-Bessemer and General Electric employee who has been in building railroad locomotives for his whole working career, and who is quite an aficionado and a rail historian himself. Mike was very instrumental in helping me develop this presentation, providing material. And my brother sitting next to him, my brother Bob, today's his 80th birthday. So, we can sing happy birthday over cookies later.
Would you be offended if we sang to you?
Happy birthday to you. Happy birthday to you. Happy birthday, dear Robert. Happy birthday to you.
Thank you. Were you offended? No. Oh, okay. Just checking. We could take it back. Unsing it.
Okay, we can get started because I got a lot to say. Believe me, and the rest of my friends here, without me introducing them all, they'll probably agree that sometimes I just can't keep quiet. So if you can hit the lights, we'll get started.
Even if your neighbor across the street doesn't know you're over there.
Yeah.
You got quieter in your older years.
I'm actually the next block down.
Next block.
On the other side of the street.
We're only ever temporary stewards, and there's no guarantee that what we save today will be safe tomorrow. But today is ours, with the hope that what we pass on will be entrusted to those of a similar mind. Hi, my name is Vinson Skibo, and I work for the railroad. I work for CSX, and this is my office. I spend most of my days right here, and for the most part, pretty much most of my nights too. I haul everything from coal, stone, coke, and various aggregates to brand new automobiles, slab steel, and pipe. I haul double stack containers full of everything from apples to lobsters to tennis shoes to washing machines and anything else that Amazon Prime will drop off at your front door. I also haul hazardous materials, ethanol that's going to go in the gasoline that you burn in your car, to bacon oil, and that's with 2 Ks, to liquefied petroleum gas. Also, my trains can have a mixture of absolutely everything from plastics to plate steel all on one train itself. Sometimes I haul a few other specialty items also. Also, the world's largest railroad car, designed specifically to come apart in the middle and bolt onto the sides of containment vessels built for nuclear reactors. And my friend Nate here, who's sitting next to my brother Bob, he also works on these cars too. Now, I work out of Newcastle, Pennsylvania, and travel west on the old Baltimore and Ohio main line. Now, I've gone to quite a few different places from there in my career, but for the most part, I travel west, going through Youngstown. This is the old B&O station there in Youngstown. Head on through Kent and Ravenna, which takes me then through places like Akron, before I end up in a town formerly known as Chicago Junction. It was renamed after the president of the Baltimore and Ohio Railroad, Daniel Willard. It's called Willard, Ohio. There my trains are broken up perhaps into smaller pieces, put back together for other trains that go to places like Chicago, Garrett, Indiana, Toledo, and Detroit. Before I get there, sometimes I make a left-hand turn, go south to another small town called Crestline, Ohio. There I'll hand those trains off to other crews that will take them on to places like Columbus, Cincinnati, Indianapolis, which then they further pass them on to St. Louis and other places further on towards the southwest. I also go west of Willard to the Intermodal Container Transfer Facility, which is located about halfway between Toledo and Findlay, Ohio. This little town is called North Baltimore, of all names. And there, the double-stack container trains pull in from places such as the Port of Baltimore, the Port of New York, and the Port of Boston, where those containers sometimes come off of the trains, are placed on trucks, go to distribution centers. Sometimes the trucks bring them in, place them on the trains, and sometimes the cars on the trains are swapped out onto other trains, and then they move on further to other destinations. Places like Chicago, and even straight through from this location with crew changes, they may go as far as the Port of Los Angeles and the Port of Long Beach. We've all seen in the news over the past year or so 40, 60 ships lined up with containers ready for offloading at the Port of Long Beach and Los Angeles. Our trains go to those locations as well. Now these trains are huge. From the top of the rail to the top of the double of the second container, it's 20 foot 2 inches. Sometimes these trains have been over 18,000 feet long. That's well over 3 miles, and they are not slow. I run these trains at 60 miles an hour. That's the limit that we have on our particular run. Further out west, some of these trains may go 70 miles an hour. Now, a lot of times I hear people say, well, we thought the railroads in this country were dead. Not the case, my friend. A lot of times they compare us to what they see on television with the passenger trains in places like Japan or in France. Now, we don't have that type of passenger service here, and it's kind of like comparing apples and oranges. You know, Texas and France are about the same size. It would be easy to spend a lot of your government money to build a passenger service in an area that size. But in the United States, we have vast distances, and we have a lot of freight to move. No other country really compares to what we have here in the United States. This train in particular, this is a train of nothing but 40-inch gas line pipe that is getting hauled to a destination in Ohio that they were actually going to bury in the ground to transport natural gas. Now, every time that I go to work, there's almost a for certain that the locomotives that I'm going to operate are going to be one of these type. They're going to be manufactured by General Electric, or the newer company now which owns General Electric, Wabtec. Wabtec is actually Westinghouse Air Brake Technologies, or the old Westinghouse company. Now, what really brings this home to Grove City as the engine blocks that are manufactured here in town are located right inside the car body, right underneath what we see the CSX logo. CSX is the company that I work for. And so think about that. When we look at the trains that I'm hauling and all of this freight, and not only on my railroad, but in the United States and across North America and in many other parts of the world, the major builder of locomotives that haul these trains and the engines that are in those locomotives are actually manufactured right here in Grove City. And I think that's something that we in this community and in our region really need to be proud of. And it's something that we really maybe are unaware of. And I don't believe that General Electric or Wabtec are maybe even aware of the fact that their place in the industry may not have even been possible if it wasn't for what happened right here at the Cooper-Bessemer plant so many years ago. And that's what we're here to talk about. We're going to be talking a little bit about the Cooper-Bessemer's rail history. And, well, this is actually part one. When I started to put this presentation together, part of it also was going to include some of the items that were actually saved in the old hog yard. If some of you are locals, you remember the storage yard that was back in this part of the plant, that my friend Nate, who is here tonight, he and I worked last year to get some of those pieces of equipment, along with Mike Schley, to the museum, a couple of museums. Once all of this started to come together, I realized that there was more material than I could actually do in one showing, and I spoke with Kathy, and she was more than amenable to actually providing another presentation for me later on in the season. So in the fall, we'll be talking in a second part with that. But tonight, we're going to be looking at how the Cooper-Bessemer actually had an impact on today's railroad industry and what part of that has actually been saved. And this is what started it all for me anyhow when I first moved here 27 years ago. As the Cooper shut down and the overhead cranes were removed, they started storing it on this little flat car right here, which actually turned out to be the frame and wheels from a steam engine's tender. The tender provided the water and coal for the steam locomotive. That got me interested as what was going on over there at the factory. Now, again, this we'll talk about in more detail in the second part of this presentation later on in the fall. So when I started to put this presentation together, I went back to the original source. We see this picture upstairs. This was the first steam locomotive built west of the Appalachian Mountains by Cooper over in Mount Vernon, well before the merger of Cooper with Bessemer to form the Cooper-Bessemer. Again, as I put all of this together, well, it got to be a little too long of a presentation, so I had a, basically, as they say in Hollywood, it ended up on the cutting room floor. So we're going to cut right to what was going on here in Grove City. Now, most of you are aware of how the Bessemer was providing supplies and material for the burgeoning oil fields here in western Pennsylvania. And they also, strangely enough, for a landlocked company, was starting to build engine blocks for the marine industry, for ships, such as this one here, that belonged to Charles Sorensen of the Ford Motor Company for his yacht, which was a direct drive reversible engine that drove the propeller shaft. They also built engine blocks for both for private and for commercial uses. Now, out on the railroads, however, the turn of the 20th century, steam was king. Steam was providing the power for the passenger trains and for the freight trains of the day. And there were several major manufacturers by this time. The small builders such as the Cooper and other manufacturers went by the wayside, and there were really about 3 major builders. However, some railroads, larger ones such as the Pennsylvania Railroad, had manufacturing facilities of their own to build specific locomotives. Now, as trains began to grow in size because of something that happened in 1893. There were so many injuries occurring to workers that the Safety Appliance Act was passed, in which the railroads were then required to have something called the Janey coupler. This eliminated the old pin and link coupling system, which caused a lot of injuries and loss of fingers, hands, and limbs with brakemen who worked on the railroad. This was the second most dangerous job in the country next to coal mining at that time. The other item that was required to be on trains because of this act was the Westinghouse air brake. Now, the railroads had 7 years to comply with this congressional mandate, and this was kind of a problem for them because they had to pay for it. And anytime you force a company to pay for something, well, they get a little irritated. Now, actually, in the long run, this was a windfall because this allowed them to have larger trains, faster trains, bigger locomotives, bigger cars. And this also aided in the development of the industrial age. As they were able to haul more products to the markets also grew. We started to see cities get larger as well. And this also caused a problem. We started to see cities like New York and Cleveland become concerned with smoke pollution. As the cities grew, you got to remember the urban centers grew. And at that time, people were heating their homes with coal. They were also cooking with coal stoves. Now, cities such as New York and Cleveland enacted smoke abatement policies. So some of the manufacturers looked at other mechanisms by which they could transport the trains. General Electric early on in 1893, the same time that the act was passed, looked at building what they called a heavy rail electric locomotive. Kind of looks like a trolley. And they had already been building components and electrical motors for trolleys. But they considered this one heavy rail because it was designed to move freight. Now, this was shown here at a release date for 1949 for the gas turbine engine we see in the background. And I'm pointing this out specifically because eventually this had something to do with Cooper-Bessemer. Now, this particular unit is still in existence at the National Museum of Transportation in St. Louis. The electrical locomotives began to grow in need and in popularity, and General Electric took the reins for this. They built engines for the Baltimore and Ohio for tunnel service, which we have to remember now, steam locomotives still produced all of that emissions in tunnels, which caused the crews to become asphyxiated. So they needed to replace them with these electric locomotives. These were used underneath the cities of Baltimore and Washington, D.C. Out west, General Electric started to produce locomotives that were growing in size, such as this one for the Butte, Anaconda, and Pacific Railway, and for the Milwaukee Road. It's interesting to know that within a few short decades, the size of these locomotives and their power grew exponentially. And soon their capabilities not only were able to match, but they soon were able to exceed the power of many steam locomotives. Almost to the point where shortly thereafter, they were able to, railroads such as the Milwaukee Road were able to electrify entire divisions of their railroad. This was possible mostly because the fact that many of the rivers and the Cascade Mountains of the Pacific Northwest were getting hydroelectric dams. Now, other areas such as Cleveland had these smoke abatement policies, and they developed an electrical system around the cities to encircle them, and the Cleveland Union Terminal System was developed. The General Electric, along with the American Locomotive Company, in 1929 built a series of these P1A class locomotives. Now on the top here they have these devices called pantographs. These were the connection between the locomotive, and these are actually in the closed position that would open up and touch the top of the electric lines. These were already rated at almost 2,500 horsepower. When a steam-powered train would come in from the east, let's say the 20th Century Limited would come in from New York City, once it hit the east end of the city around Collinwood, one of these engines would be placed on the front of it, it would pull it into the Cleveland terminal, passengers would get off, it would take that train off to Berea on the west side of Cleveland, a steam engine would be put on, and it would take it on to Chicago. Now, the other avenue, now they couldn't put electric lines all throughout the United States, so they looked at other avenues as well. They began to look at what they called originally oil electrics. We now call them diesel electric locomotives. And the reason they say electric is there's no direct drive shaft between the engine and the wheels. The engine itself here turns a generator, creating electricity in motors that are inside the wheels. Now, they built 3 of these in 1918. None of them were of any success and were returned to General Electric shortly thereafter. The one here on the bottom was actually armor plated and was going to go to the trenches in France in the First World War. But hostilities ceased and they was returned to General Electric shortly thereafter. And these were not very powerful at all and were not a success. But that did not deter General Electric. They started to continue along and built several more in a boxy type of situation as we see here, and they were kind of nicknamed box cabs. They went to a company called Ingersoll Rand of New York, and they used an inline 6-cylinder engine that was rated at only 300 horsepower. Now, this was around 1924. And by 1925, we see one of these Ingersoll Rand GE engines right here at the test plant in Erie, PA, being tested. And some of these cars were converted to haul wood so that they could put specific amounts of wood in them to have specific loads behind the engines to test their pulling capabilities. They went a little bit further to try to create something a little more powerful, and they come up with this little beauty. It actually had two engine blocks inside. This is an overhead view. Two engine blocks side by side inside the same car body. This is where the engineer sat, right up front inside that little box cab. And some of these went to the Long Island Railroad. Now, these weren't quite that powerful either, and could barely replace the capabilities of a small steam locomotive. Some went to the Central Railroad of New Jersey, and most of these operated in and around New York City that had their smoke abatement policies. They also had electric lines coming into New York City as well. So these engines were used in switching duties, which meant that when a train would come in with freight cars, they would break those trains apart and deliver those cars to their individual shippers and to the individual freight houses that they needed to be unloaded at, or they would put them on barges to be floated across the river into the cities themselves. The Erie Railroad also had worked with General Electric, who also chose Ingersoll Rand and the American Locomotive Company to build some units. And this is in 1925. But you can see these two were only 300 horsepower units, not even close to what even a small steam locomotive could pull. And so you can see as the straight electric locomotives were surpassing what a steam locomotive could do, the diesels were faltering. And General Electric grew concerned about that. They needed an engine block that could do a little bit more. So they needed to go elsewhere. And that's when they turned to the Cooper-Bessemer. And they were well aware of what Cooper-Bessemer was doing in the marine engine block arena. So in 1936, they partnered with Cooper-Bessemer to develop this locomotive. There were several of these built, 5 of which went to the New Haven Railroad. At the same time, several were built using Ingersoll Rand engine blocks. Those went to the Republic Steel and to the Atlantic Coal Company. These had interchangeable engine blocks. They could actually take the Ingersoll Rand out and put in a Cooper if need be. And I think this was a design philosophy just in case they needed to do that in the future. But that was never the case. It never came to be. Now, it says here that these units were nicknamed the Model Y. One thing I know for a fact is railroaders love to give things nicknames, especially each other. Now you can't give yourself a nickname no matter how much you would like to. It has to be earned, and believe me, you know, they're usually well deserved.
What's yours, Vince?
You know what? My wife asked me that one time. You know, she did. You know, and I says, well, if I have one, they're afraid to say it to me into my face. Okay.
Just had to put you on the spot.
Just had to put me on the spot. So for some reason they nicknamed this one a Model Y, and why they named it Y, well, we don't know why at this point. Okay. And this page is out of a book called The Second Diesel Spotter's Guide, and it says in here that they thought that maybe one of these had survived, but at this point we're really not sure. Now, I found these 2 photographs actually on the internet. The image on the left, I believe, is an advertisement that came out by the Cooper-Bessemer. And there was a couple very interesting things I seen when I look at this. One is it says that the Cooper-Bessemer is one of the oldest engine manufacturers in this country. In building diesel engines for locomotives, nothing can take place of experience. There is no mention whatsoever of General Electric in this at all. Okay? And they had never built a locomotive before for the railroad. Not only that, the only component in this in here that's a Cooper-Bessemer is the engine block. The car body, the headlights, the generator, the wheels, the traction motors, everything else is a General Electric component. Okay. The other photo here is this one, and the number is actually wrong. It says 0907. The highest number on the New Haven Railroad is 0905. I think this may have been airbrushed on. This photo may actually be at the Erie plant somehow. And when I first saw these photos, I thought, this is kind of an ugly duckling, or, I really didn't like it, but when I think of the year that it was built, 1936, and the more that I look at it, the more that grew on me, and I really, really do like the looks of this engine. And I hope that somewhere somebody was able to save one of these headlights somewhere in a museum or somebody's private collection somewhere. I really hope. Now, eventually, the New Haven sold all 5 of their locomotives to the neighboring Bangor and Aroostook Railroad in Maine. And these locomotives continued on and survived for quite some time. They had some other marker lights placed on them. And one of the other things I noticed, and it's kind of hard to see, right down here on the bottom, they have a Y2. That's a classification that the locomotive had while on the Bangor and Aroostook. One of the things that railroads do is if they classify all of their locomotives, steam and diesel, and typically they put that classification number on the cab of the locomotive around the numbers somewhere, and that's what there are there. I did a little more investigating, and I came up with this little table that shows that the numbers of the New Haven, under New Haven, what they were, and the first one was built in 9 of 1936. The last one was built in January of 1937. 902 and 903 were built somewhere between 9 and 11 of 36. Don't know exactly where, and the builder serial numbers. The classification for them was a DEY-2. The D for diesel, E for electric, and again, we don't know why, and 2, which I believe means that it had a 2-axle truck under each of the, for the wheels. The Bangor, corresponding Bangor and Aroostook number, they carried over the Y2. And when I looked on the New Haven Railway Historical Society, actually they spelled the whole New Haven Railway out, which I won't get into, but they showed that the middle 3 units were scrapped all by 1962, and the first one, number 30, and the last one, number 34, were traded into electromotive divisions or General Motors in 1966. Now the railroads will trade in locomotives just like you would trade in your car when you go to buy a new one. Sometimes it's just a straight trade-in for perhaps scrap value or just to get them off the books. Sometimes the builder will use components off of those locomotives for the new engine. Now, we really don't know what happened to them after there. Chances are they were scrapped, but if one of them ever turns up anywhere, or if I find out different, I will definitely make note of that and make sure that we keep track of that for posterity's sake. Now in 1937, General Electric returned to Cooper-Bessemer for the building of these little center cab units. There was actually 2 engine blocks, one here and one on this side, and those were Cooper engines, and these were built for the Monongahela Connecting Railroad, and they also built several for the Ford Motor Company for switching their Ford Motor Assembly plants. These had a little more streamlined look to correspond with Ford's automobiles of the time. A quite little handsome look there, I must say. Now these engines remained with the Ford Motor Company for a period of time, but were eventually sold to a short line railroad in northern Pennsylvania. When that happened, I really hope that these bolt-on Ford emblems and numbers also survived. Maybe, hopefully, an employee snuck them home somewhere, and they might even exist in someone's automotive collection somewhere, which maybe we need to keep a lookout for somewhere along the line. Now, fortunately, those things went to the Wellsville, Addison, and Gelton, and our own Mike Schley Even though his modesty might tend to say no, he is quite the historian on this particular railroad. And he was able to find this photograph that come from an unknown photographer of two of these units in service on the what they call the WAG. This is actually the same train. This is the lead locomotive here, and this is a train of solid pipe on a large horseshoe curve that loops all the way around to here. And this is the rear of the train with the second locomotive and the caboose. Looking at this, we see the radiator and headlight. Here's a bell, and here's a fan blowing on the radiator. One of the engine blocks. This is the exhaust port. We have the headlight, and this is the control cab where the engineer would sit. Another exhaust port, the other engine, another radiator, and a second headlight and radiator right here. Fortunately for all of us, one of these engines has been saved. It is at the Lakeshore Railway Museum in Northeast PA. If you don't know where Northeast is, it is located just off of I-90 east of Erie, PA, before you get into the New York state line. Now this is probably the oldest locomotive with Cooper engines inside of it, and that is a beautiful orange and cream with black stripe paint scheme on that locomotive, and you can see that locomotive today. And it is really not that far away, about an hour and 10 minutes, hour and 20-minute drive, unless it depends on how fast you are. Now, during the Second World War, a lot of productions for most manufacturers in the United States was regulated by the War Production Board. So a lot of the growth in the rail industry for diesel locomotives was put on hold. And so we did not see a lot more production coming from that venue. A lot of the engine blocks that was coming out of the Cooper-Bessemer was actually put back into the Marine service. We see such things as those engine blocks going into ships such as this Fletcher-class destroyer. Some of these were actually, not this particular picture, but these particular units were featured in some of the Cooper-Bessemer publications. And for such ships as the USS El Chiba, which was mentioned as a award-winning ship in the Battle of the Philippines. Now, one of the interesting things about the publications, even in the Cooper-Bessemer publications, is that during the war, there was a lot of misleading information, or a lack of accurate information, I should say, because if those documents got into, let's say, Axis power hands, they did not want specific information to be known about these ships. It was led to believe that this may have been a Liberty ship, when in fact it was a naval attack cargo ship. We could see that it is bristling with gun emplacements from bow to amidships, all the way back to the stern. And this did have Cooper-Bessemer components inside of it. Primarily though, a lot of their direct drive marine engines went for coastal patrol vessels, naval tugs. We see 3 or 4 of them in this shot here, and larger combatant vessels such as this cruiser. And again, the numbers on this cruiser are not on the photograph. I believe this may be the USS Houston that was sunk while defending a flotilla of ships heading to Australia when they were jumped by a Japanese task force. Now, the only manufacturer permitted to build diesel locomotives during the Second World War was General Motors. Early on, under the name of Electromotive Corporation, they built a set of locomotives here called the EA and EB for the Baltimore and Ohio Railroad. Now, it says that these were 3,600 horsepower. That was actually enclosing 4 engine blocks, one here, another here, and a second unit, in an EA and EB. Now, we say an A unit because it has a control cab for the engineer and fireman to sit in. The B unit has no control cab. They also produced what they called a demonstrator unit called an FT. Now, a lot of people think that this may be called freight. Actually, it meant F for 1,400 horsepower and T for twin. Each one of these only had a 700 horsepower engine block in a twin unit. This was a semi-permanently coupled unit here. So this was only 1,400 horsepower. It took all 4 of these to produce 2,800 horsepower. Still not as much as even a medium-sized steam locomotive of the day. Here's the real thing. Everybody thinks that a diesel locomotive beat out the steam engine in the 1940s and 50s because of its pulling power. It did not. The steam locomotive had a lot of maintenance requirements. It was the diesel locomotive's availability per month that really made it win out over the steam engine. Because of the moving parts on a steam engine, if you ran a steam engine 10 to 12 hours a day, it may require as much as 8 hours a day of maintenance afterwards. Where a diesel locomotive, that number was incredibly reduced, drastically reduced. All you may need to do is put some fuel in it, check the brake shoes, put some sand in it so that it would get additional traction, and maybe a once-over. Now when a steam engine boiler went cold, it could take hours and hours to heat that boiler back up again. With a diesel locomotive, once you shut it off, it was no more like than starting a car. Threw a couple switches, push a button, and vroom, it started right up. It was that time availability that made these locomotives far superior to the steam locomotive, and they quickly basically took over from the steam engine. It wasn't until years later that their horsepower capabilities would exceed that of a steam locomotive. Fortunately for all of us, several of these have been saved for historical posterity. This past year, the good folks at the Baltimore and Ohio Railroad Museum in Baltimore were able to cosmetically restore their surviving EA unit that we see here, which is really a beautiful locomotive. There's also an FT unit stored at the Museum of Transportation in St. Louis. Now, during that time, the Cooper-Bessemer News reported that their locomotives were hard at work for the war all over the world, and this is in 1944. However, when we look at the actual numbers that were built between 1937 and 1945 for road switcher and mainline applications for freight, we see that there were really only 45 units built. Now, this does not include industrial applications, industrial switchers in factories. And I know the picture does show a factory in the background. Those numbers are hard to obtain because this was wartime production. And any of those switchers that were built for wartime production use pretty much went to the military. The military might use them in naval shipyards, ship them overseas for use in various applications throughout the various war zones that we saw in the European and throughout the Pacific theaters. Now, after the war, a lot of those engines came back home, and the factories and industries in the U.S. were ready to get rid of their steam locomotives and acquire those second-hand locomotives, which they did. And many of them happened to work right here close to home. For example, the Carbon Limestone Company, which is located in Hillsville, PA, between Newcastle and Boardman, utilized several of them, but unfortunately they were scrapped in the 1970s. By poking around a little bit, I was able to find this beauty. This one was used at the American Steel Foundry in Alliance, Ohio, and right now is stored and preserved at the Mahoning Valley Railway Heritage Association in Youngstown. This is probably the oldest and closest to Grove City of the Cooper-Bessemer GE war-era switching locomotives. This actually has the Cooper engine inside the car body here. And I really hope that those headlights that are stored somewhere at the Mahoning Valley folks have, and perhaps in somebody's collection, that they just remove them to keep vandals from damaging them or from stealing them. This photo is a little bit older, so when I got this, so I hope that those folks had a chance to clean it up. They have an open house a couple times a year, and so right over there in Youngstown, we actually can go and take a look at this, this beauty right here. And this gives you an idea in real life of what those engines from that time period and pre-war actually looked like. After the war, GE returned to Cooper, and they started to look at their 660 horsepower engines to build what they called their 70-tonners. There's some conflicting information from the Cooper-Bessemer manifold about these, saying that by 1945 they were such a success that they returned to get 35 more of them. However, it wasn't until November of 1946 that these engines actually went to the Saratoga and Schuylerville Railroad. Now, several of these, actually 25 for that matter, went to Brazil. They actually went in a 3-axle truck design for use in some of their freight and passenger service in Brazil, and we're going to talk a little bit about them here in a moment. Some of these were actually built in a 95-ton version, which just meant that it was the same thing, but the frame was a little heavier and thicker, and that was used more for pulling heavier loads depending on the application. Over 260 of these were built by 1950, and one does survive at the Oregon Rail Heritage Center in Portland. Now there may be some others scattered around, but this one here just had a really pretty picture. And in order to, it would be quite a task to start to track down every single one, but as they do come to my attention, I will try to take note of wherever some of these Cooper-Bessemer engined locomotives still exist. Now, at the end of the war, builders such as Baldwin, Alco, that were building steam locomotives knew that the time of the steam engine was coming to an end. So they looked to start building diesel locomotives themselves. Baldwin, of course, went to build their first prototype, and they came up with this particular locomotive. And the reason I'm showing this is, this locomotive actually tested on the Bessemer and Lake Erie, and it ran right through Grove City at its testing time. Eventually, once its test period was over, it returned to the plant. They decided to make some tweaks to it, upgrade it a little bit, and they came up with this thing. Now, of course, the railroaders took one look at this thing and saw all the wheels underneath it, and they decided to call this thing a centipede. These things were built for the Pennsylvania Railroad, the Seaboard Airline Railroad, and for the National de Mexico for an export. Prior to this actually ending up on the Union Pacific, a lot of problems came to light on the Pennsylvania Railroad. The Baldwin Locomotive Works still had the mindset of building steam engines, building one at a time from the ground up. And what happened was, every time they put the electrical wiring in this thing, they built it differently. This one was wired different than this one, than the next one.
Oh my.
Okay? Whereas the railroaders were now getting used to what General Motors was doing. They already had that assembly line type of mentality, building things consistently the same way. And so eventually this gave Baldwin a real black eye, and eventually they ended up going out of business. American Locomotive Works, on the other hand, had a little different philosophy. They had already been working with General Electric to build electric locomotives. They already had somewhat of an assembly line process concept, and they were already working with General Electric. These locomotives had General Electric traction motors and General Electric wiring and generators inside the car bodies. American Locomotive Company was a lot more successful, and they remained in business all the way up into the 1960s. However, their engine blocks weren't quite as good, and they leaked a lot of oil. That oil burned inside the engine, producing an awful lot of smoke. And the railroaders pretty much gave them a honorary steam locomotive. They graced them with an honorary steam locomotive title because of the amount of smoke that came out of the stack. Another builder was Fairbank Morse. Now, I believe this is a beautiful, handsome-looking locomotive from the time. Now, Fairbank Morse had beat out a lot of other builders of engine blocks for a naval contract in the Second World War because they had what was called an opposed piston engine block. One piston was high up at the 12 o'clock position, the second one down low at the 6 o'clock position, and the main drive shaft was in the middle. This gave it a tall, narrow profile. The Navy loved that because they could put two of those engine blocks inside the hull of a submarine. And they actually were in over 50% of the submarines built during the Second World War. When the war was over, and of course the nuclear sub was on the horizon thanks to Mr. Rickover, the Fairbank Morse looked to build railroad locomotives. Now, they had some issues as well, and to try to iron those out, they turned to General Electric also. Now, General Electric tried to help them out, and they built some of them in Erie. Now, there were some design changes, and easy spot of these Erie builds, as they were nicknamed, was the windows were a little rounder compared to the original builds, and where the noses had a nice squared angled off, they were a little rounder. However, these did not do as well either, and the Fairbank Morse went out of business by 1952. Some of the mechanical engineers from Fairbank Morse ended up at Cooper-Bessemer. Gentlemen such as Melvin Helmick, who ended up being a resident of Grove City for a great many years, worked for Fairbank Morse and came to Cooper. The real winner in the whole deal was General Motors after the war, with their E7 class locomotive, seen here with their demonstrator train of tomorrow. The E7 ended up being the most prolific passenger diesel locomotive in history. However, these were all the glamour girls of the railroading industry. What was real moneymaker and what the General Electric really wanted a piece of was the locomotives for freight, because they knew that's where the real money was going to be. And entering into the picture at this time is this gentleman, James Chrisman Rhodes. James Chrisman Rhodes worked for General Electric, and he actually became quite well known, especially in the design area in the in the 1930s, for being granted patents for turbine components that were placed in steam turbines for the Union Pacific Railroad. Now, these look like streamlined diesel locomotives, but they're not. These are actually steam turbines. The railroads, they had steam locomotives. They were very amenable to the coal mining companies, and so they looked at these steam turbines. But none of them were successful, either on the Union Pacific or any of the other railroads. However, and we're going to diverge a little bit here because of Cooper's interfacing with the turbine manufacturing here, is the Union Pacific worked with General Electric over in the post-war years to develop locomotives such as this gas turbine locomotive, which we saw a little bit earlier in the release of these when we saw the picture of the very first heavy rail electric locomotive. Now, when these locomotives were built, they were able to achieve very high horsepower ratings that met and exceeded those ratings equivalencies of the largest steam locomotives that had ever been built. Now, a turbine works wonderful when it's in a ship at sea, when it's in a power plant, or perhaps in a hydroelectric dam, because it spins at high rates for long periods of time. Well, that also works well for the Union Pacific because it has vast distances that it needs to cross. So that turbine can run at high speeds for long periods of time. But it also burns a lot of fuel. And what they had a lot of access to was the fuel called bunker C crude oil, which was prevalent across Southern California. It was cheap because there was no other use for it. So they were able to use that fuel burning in those gas-guzzling, let's call it, turbines. Now, they used the tenders of old steam locomotives to haul this fuel around. Now, they went those vast distances, but trains don't always go fast and over those long distances. Sometimes they need to slow down, they go into yards, they go through stations, they need to stop for signals, they need to move around servicing facilities, what have you. That's when they turned to Cooper-Bessemer. And Cooper-Bessemer provided an auxiliary engine to these units in order to run them at slow speeds, but also to start that turbine. The turbine couldn't start itself. The Cooper engine was used to provide the power necessary to spin that turbine up to speed and also to heat the fuel. because the fuel needed to be warmed up in order to get that turbine running efficiently. Now, all of those engines basically were gone by the 1970s because, now, does everyone remember the old saying, modern living through chemistry? Okay, well, something happened with bunker C crude oil. That's when they found another use for it. Plastics. That's what our plastics are made out of. They started to make more things out of plastics in the 1960s, and the price of bunker C crude went up. And so did the price for their fuel and the price to operate these locomotives. So they needed to get rid of them. They started to become basically a white elephant. Now when we look at this here, we see that the steam engine tender in the back is what hauled all the bunker C crude. And now this is all considered one locomotive. This section here is where the turbine was located. It turned a General Electric generator, which provided power to all of these wheels. There was a traction motor in each one of these wheels here. Okay, and in the control cab, this is where the locomotive engineer sat to operate the engine, or the locomotive. And right in here is where our Cooper-Bessemer engine was located. This was to move the whole thing around when the turbine was shut down and when we were going to move it at low speeds. Now these had a nickname also, the Big Blow. That's because the turbine was so powerful, when the exhaust came out of it, it was at over 150 miles an hour, at over 800 degrees. Now this became a problem. Now, I can tell you from experience, when your air conditioning in a locomotive doesn't work, it gets hot in there, especially in the summer. And these things ran through the desert. So when you have to stop somewhere and stop for a signal, I'll tell you, you want to stop underneath a bridge because that's where your shade is at. When these things stopped underneath a bridge and these things were still spinning at a high RPM, that exhaust would go up and it would actually melt the asphalt on the bridge above it. Well, the local highway departments were not too happy with Union Pacific at that point. Okay, and so that was a bit of a problem. Now, once they got rid of these, they actually saved two of them. One is at the Union Station in Ogden, Utah, and the other one, seen here in this photograph, is at the Illinois Railway Museum outside of Chicago, and they both still have their Cooper-Bessemer engine inside of them. Okay, back to Mr. Rhodes here. We saw those little Cooper engines that were sent down to Brazil. Well, in 1948, General Electric sent him down there to do an evaluation of those in the field. He met some Cooper folks that were down there as well, and he was very impressed, not only with the locomotives and their performance, but with the folks from Cooper. When he returned to GE, and by 1951, GE had already thought about building a road freight locomotive to compete with General Motors and American Locomotive Company. Now, they assigned him with a team to travel North America and Europe to find who was manufacturing the best engine block in the world at that time. And they did not want to tip their hand to EMD, and also to Elco, who they were still in a contract with. So they said that they were only going to do this for foreign sales only. They weren't interested in the domestic market. So they didn't want them to know that. And by 1953, once their evaluations and investigations were complete, out of all 45 engine blocks that they had looked at throughout the world, here's where they found the best one was located. Right here in Grove City. In a quote from Mr. Rhodes' son, he said that Cooper-Bessemer four-cycle engine design was the most suitable for GE's entry into the locomotive business. Now, when he says locomotive business, let's be more specific. He meant the domestic freight locomotive business. That's what they were truly interested in, because they wanted to knock them, the General Motors, right out of the #1 seat. And this is the engine block that they were looking at the time, the FW and FV engines. Specifically, the F stood for a 9-inch piston stroke and a 10.5 cylinder bore. The W meant that was the inline engine. That meant all of the cylinders were in a straight line, and the V meant, well, that was a V-type design. Now there were some, the engine was actually designed in that submarine engine block competition back in 1942 for the Navy. And all of the other builders we see, including Alco and Fairbank Morse, along with General Motors, was involved with that as well. However, the Cooper-Bessemer was rejected. And I think they were rejected for one particular reason at that time, and that was because one of their attributes. It was because the cast iron frame that they had was out of one of their licensed and patented gray alloys called Meehanite. It had a superior strength and ductility, yes, which was one of their attributes, but at that time it was not a proven technology, especially in submarines. And what the Navy was really interested in was how well could the engine block in those submarines sustain a depth charge attack, and the shock waves being that would be placed upon those engine blocks. The last thing they needed was those engine blocks to crack during a depth charge attack. And well, it probably would have done pretty well, but in this case, I don't think the diesel locomotives in freight service in the United States were going to undergo a depth charge attack at any time, even during the Korean War. Okay, so one of the other positives about this was the self-contained power cylinders. That is, every cylinder could be removed separately without having to take the whole engine block down. And this allowed for a quick replacement. In case one of them had a problem or a maintenance issue, you could replace one rather quickly, and that would also show up as an attribute quite early on. One of the other things was turbocharging, and Cooper-Bessemer offered this. They actually worked with the original inventor of turbocharging, Dr. Alfred Bucci, and they worked with him in even some of the earlier tests in 1934. Other companies such as General Motors had a different philosophy with turbocharging. Theirs was, if you need more power, buy another locomotive and put it on your train, okay? Which basically turned around and came back to bite them later on, and they eventually would put turbocharging on their engines. All of this combined later to allow the particular engine block for Cooper-Bessemer to see an incredible growth later on in its development. So, General Electric had decided to use the Cooper-Bessemer engine in their test locomotive, and they were going to call it the 750. It actually had 4 separate units. An A, B, C, and D, they were going to call them under the one number 750. And they looked at 3 different railroads, perhaps, to test that locomotive on. The Boston and Maine, Erie, and Union Pacific. Now, they looked at the Boston and Maine at first because the Boston and Maine had an excellent maintenance record. They had a superior, to most railroads, a maintenance program. But when they started to look at this, they found that a lot of their locomotives were failing at a higher rate than others. And they found this kind of odd because they had such a wonderful maintenance program. When they looked closer, they determined that that was because the runs on the Boston and Maine were very short, very hilly. It would be like you running your car, and if all you did was drive around town all day, and your town was nothing but hills, you would wear your car out really fast. You would wear the brakes out, you would wear your engines out, because you would be putting on the gas, slamming on the brakes, and so forth. And that's what happened on the Boston and Maine. The Union Pacific, on the other hand, had very long duration runs, and they never, you would run that train well into the type of range that they wanted, but maybe sometimes a little too much, and you wouldn't necessarily have those starts and stops that they were looking to see the experience. They needed something a little bit more in the Goldilocks zone, and that's where the Erie Railroad came in. Erie Railroad also was close enough to the Erie plant in the GE plant in Erie, PA, and also to both of the Cooper-Bessemer facilities in Grove City and in Mount Vernon. It also had the ability to pull heavy manifest trains in both directions over its main line. That is, it serviced a lot of cities, requiring it to haul freight in both directions. If you were to go to a railroad that hauled a lot of coal, you would haul heavy trains of coal in one direction and light trains of empty hopper cars in the other. So this would give them the ability to run their test train at a high throttle position for long durations in both directions, something that they really needed to do to test the particular engine. Okay, so now in those 4 units, 2 of them ran with 1200 horsepower, 12-cylinder engines, and 2 of those units ran with 800 horsepower engine blocks in 2 of those, producing 8-cylinder engines in 800 horsepower each. And they were numbered in the ABs in the 1200 horsepower. A unit had the control cab, as we see here. The B unit did not. And the 750 C and D had the 800 horsepower. The D unit also had a control cab. The C unit did not. We're going to follow a little bit along with the C unit for various reasons. One is eventually that particular engine block in July 2020, the American Society of Mechanical Engineers declared the Cooper-Bessemer FVAL 8T engine a historic engineering landmark. The Cooper-Bessemer serial number 5133 is officially one of only 275 worldwide ASME landmarks. That's quite an accomplishment. Quite an accomplishment coming right here from our Grove City plant. Now the locomotive was built with those engine blocks. We can see our control cab here. The engine block was inside the car body here, and this is our cabless or control cabless B unit here, and our C unit and the other control cab unit over here. This is at the test plant in Erie, and the publications put out by, of course, Cooper-Bessemer shows that it is the belief of management that an adequate market will develop in South America, Australia, and the Far East for the foreign markets. Of course, if this got into the hands of Elco or General Motors, they did not want to tip their hand saying that this was going to be to put them out of business. And we see in the publicity photo, Grove City's Melvin Helmick right there pointed out in the picture in front of the locomotive, along with a lot of other Cooper brass. Now he was on board when those locomotives went from the Erie plant onto the, from the General Electric plant in Erie to the Erie Railroad's main line. He accompanied it on their first trip on the Erie Railroad. Looking at this map that was in from one of their timetables, we see the route from Hornell to Marion. And we can see that the Cooper plant in Grove City is en route along with Mount Vernon. Now starting in Hornell, the route, and this is slightly exaggerated because it is out of a timetable, travels down and splits here at Pymatuning. The passenger route drops down through Sharon, Youngstown, and Warren. However, the line splits and the freight-only line runs through Orangeville and Cortland before it returns back to Leavittsburg and continues on to Marion. I believe that this line here is where the units were tested predominantly, because this is where the trains could run at a higher speed more consistently without slowing down, going down through downtown Sharon precisely. It does not mean that they never did go through there, but for the most part they probably went over that bypass line through Orangeville and Cortland. Now, we don't see a line in the map here, but there is a line that brought those engines. We're not sure if they went from GE to Corey to get onto the Erie or down the Bessemer to either Meadville or Shenango. We do see the line that brought those engines at one point down to Grove City here, and at Mansfield there was the B&O line that would take it down to Mount Vernon. This line that went through here was actually the line where that very first steam engine that Cooper built operated back in the 1850s. Now, on that very first run, on the return leg, leaving Marion, they're experiencing a water leak. They started to lose water. And they found that a clamp ring on the bottom of the cylinder, not just one, but on many of them, started to leak water. Now, Melvin Helmick was on that run, and he sent the service engineer, Mr. Chuck Foster, down to tighten some of those bolts. Well, then bolts started to snap. The leak worsened, and what happens when water starts to leak out of those engines? Well, those engines shut down. And right away, it was a good thing they weren't on the Union Pacific. They were real close here on the Erie, and they were towed back to Grove City. Now, in a stroke of luck, our own Mike Schley found this photograph in a box. Mike, correct me if I'm wrong, but didn't you find this in a box of photographs at a train show?
No, it was in Mount Vernon.
Oh, you found this in Mount Vernon?
And I can't remember just who or where or how I found it, but I'm pretty sure it was there.
But this is actually in the hog yard there when they were returned to on their trip to Grove City. In the photo here, we can see one of the diesel-powered whirly crane off here on the right, here. And at this point, the cylinder liners were redesigned, and because they had that individual design that was an attribute to these engine blocks, they were replaced quickly. All 40 of them, as a matter of fact, that were in all 4 engine blocks, and the locomotives were returned for testing. You know, Mike, I looked at this picture rather closely, and it looks like this may be exhaust from the actual engine rather than from the factory. These may be under their own power at this point.
Might have had them back together at that point.
Yeah, they may have been back together at this point. So these engines then returned back to service. We see them here in a color photo. This is from Mike's collection. I did bring my copy, and it's up there on the table there that's framed. This is from a publicity photo that went out to individuals, and they were framed actually in Erie, PA. And they went back out for continued testing. Now, at one point, just like humans, if we were to climb to the top of a mountain, the air would get thinner and we would have trouble breathing. Well, engines aspirate just like we do. And so some tests had to be done in order to determine how well they breathed at higher altitudes. So one of those engine blocks, the 750C, returned down that B&O line from the Erie down to Mount Vernon to undergo tests. They underwent some temperature tests and to undergo some high altitude tests where they simulated some 6,000 foot altitudes. They also then, there's nothing better than taking them out into the real world, okay? And so they shipped that unit out to Sherman Hill, Wyoming on the Union Pacific for further testing, which resulted in invaluable data according to this information from the Cooper-Bessemer manifold in March of '56. Well, who else but Mike Schley pulled this out of his collection? This is the actual tests being conducted in January of 1956. The Union Pacific provided a caboose for the folks there doing the tests to keep out of the cold and to continue working. Now, the engine block inside the car body here was one of the 8-cylinder engine blocks, which would have been a little bit smaller than the 12-cylinder, and I believe was to allow for a little bit more room in here for some of the test equipment to be installed for those tests. Now, during that period, the other engines continued along with their testing. Eventually, they were all brought back together. And other than minor maintenance, let's say brake shoes, you know, of course, sanding, and other little minor things, any type of major repairs to these engines were refrained from. They wanted to continue to allow these things to wear down so that when they were finally done with their testing, they could be checked over thoroughly to see how well they performed. In 1959, when they were returned to Erie, the prime movers, the engine blocks, were removed and completely disassembled. And they were completely gone over by both personnel from General Electric and by the Cooper-Bessemer. And at that point, most people thought that those engine blocks, once they were removed, were scrapped. The locomotives themselves were repainted. They had 1,200 horsepower Cooper engines installed back into them. And the head 2 engines were renumbered as 620A and B, the rear 2 as 621A and B, and they were sold to the Union Pacific. And the Union Pacific used them until 1964 when they were traded back into GE for what was known as the U50 model. We'll see a little bit of the U50 a little bit later on. However, that was not the case. That engine block out of the 750C was used in Mount Vernon at the Cooper-Bessemer facility there. And that's the one that was granted the status of the landmark. Now, that's Melvin Helmick standing in front of that engine block there before it was shipped out to the Lakeshore Museum in Northeast. These photos were generously provided by the folks at the Lakeshore, specifically Mr. Jan Nagel, as that was being offloaded and placed on a flat car there temporarily at the Lakeshore facility. Now, on a trip recently back from Buffalo, Mike and I stopped at the Lakeshore Museum. They had placed what they call a doghouse over top of it to protect it from the elements, because we all know up along Lake Erie it gets pretty wintry up there. Formally, they have not yet dedicated the engine block up there at this time. I believe, and they don't want to quite say anything just yet, but I kind of got a sneaking suspicion. Right now they're restoring their 1869 freight house up there when they want to put, or they are putting a basement underneath it to stabilize the structure. And what we see here is the basement is in place and the building is back down on top of it. I kind of have a feeling that after this is complete and if some other work is done, that they will have a formal dedication ceremony for that engine block. I really do plan on attending it, and I'm sure Mike would like to be there, as well as a few other folks, and anyone here from Grove City is more than welcome to accompany us to attend that dedication ceremony, as I believe that would be very important for folks from Grove City to be there, because that engine block was built here in Grove City, and it is quite important. Now, even before these engines were finished in their testing process, an engineering study came out. Again, this comes from Mike Sly's collection. And in that study, a couple of things were very important. They already thought that that engine block from Cooper could easily reach 4,000 horsepower. Again, this is now, we're coming to the point where one engine block could now meet the equivalency of what some of the steam engines were capable of. They also said that there was definite technical competitiveness for those locomotives to be released at a 2,400 horsepower level, and could easily then achieve a 3,000 horsepower in the very near future. In conclusion, they were eminently suited for the introduction into freight locomotive use and could be kept competitive for the next decade. However, there were some corrections that needed to be addressed because some inadequacies that they had found during those tests in that locomotive. One being fuel injection system, and the second being an air manifold system. Now, those were addressed even almost immediately, and GE began to look at it as a 7FDL engine, the same thing as the Bessemer's FVDL 16-cylinder engines. And right away, GE started to look at building a new prototype. We could see one of those power assembly cylinders going into the engine block and being attached to a generator to go into one of these new prototypes, which they called the XP24. And of course, we got all the brass standing out front of one of those prototypes named 751 in sequential sequence to that 750. And here we see the 751, 752 demonstrators out in the field. They must have been getting good use, because someone actually had to wipe the dirt off of the numbers here and the logo to make sure that everybody knew what they were and where they were from. Now, as an operator of locomotives myself and a railroader, having these ladders on the side isn't quite the greatest idea. These corners is where you really want to be, and without having them ladders there, this is actually kind of a little bit of an uncomfortable spot. So once those kind of lessons were learned, we can see their new engine for production was going to be the U25B. U for universal, 25 representing 2,500 horsepower, and the B meaning a 2-axle truck. This whole assembly is considered a truck. There were also some C's, which was a 3-axle truck. Our number sequence 753, and of course they knew what they were listening to. They put the ladders and the walkways right up front in the corners also. The first buyer to step up front was Union Pacific. They were always looking for something new, something more powerful than the last thing, because they had a lot of freight to move across vast distances. However, the problem was Cooper-Bessemer, not General Electric, owned those engines. GE didn't own the engines yet. So once orders started to come in, it was Cooper-Bessemer that actually booked those orders. They booked the first 4 right with GE. When GE went to build their first 4 demonstrator units, 2 of which had a high nose and 2 had low noses to see which the customers would like better, they actually had the Cooper-Bessemer engines in them. Also, the first 36 that were sold to railroads also had Cooper-Bessemer engines. And those railroads had to go to Cooper to buy those engines, to book those engines. Okay? Even though in 1960, GE commercially announced the locomotive. And by 1961, all of the engines that were being delivered to the railroads were having the Cooper-Bessemer labels right on those engine blocks. Those engines went to the Southern Pacific, the Wabash, Santa Fe, the Frisco, and to the Union Pacific. Now the GE also put out a publication to try to sell those, taunting their abilities. Their service was proven all over, and it was their engine, not the Cooper-Bessemer's. They had relied performance. It was brand new from the rails up. And one interesting thing that I felt that was quite unique in this publicity photo that they had in here was right here. When we looked at this photo, we see 1, 2, 3, 4, 5, and 6 locomotives. This one way in the back for the Pennsylvania Railroad, that is a straight electric locomotive. That does not have a diesel engine in it. These other ones, however, this one in the front, one of the U-25s, has a Cooper-Bessemer engine. This one right here, another one with a car body on top of it, has a Cooper-Bessemer engine. This one here and this one right here, these are built for foreign markets. They have Cooper-Bessemer engines, and the control cab for this Union Pacific turbine has a Cooper-Bessemer engine. All of these, except for the electric engine in here, have Cooper-Bessemer engines inside of them. And so they went right ahead and were selling these things. In 1961, they applied for a patent for the U-25B, and also later in 61, the sale was final for selling the drawings and the associated patents for that engine to General Electric. And General Electric officially changed the name to the 7FDL. In 1964, the patent was granted to General Electric for that locomotive as the U-25B, and basically the low-nose version was the most popular because it gave the crews operating them a greater visibility. They went into full production and sales started to blossom right away, with that going to many, many railroads across the nation. Now Union Pacific, they still wanted something large, and they needed to replace them turbines because the fuel prices were going up. They needed something with a high horsepower. So they went to General Electric and they says, well, what can you do for us? Well, they says, well, we got these U-25Bs. How about if we, let's see, 25 and 25 is 50. How about if we put 2 of them on one frame? So they come up with a U-50. Basically, it had 2 engine blocks and 2 sets of wheels and trucks on one frame, making 2 locomotives into one. And so this was their U-50. And so Union Pacific said, yeah, okay. And they traded in those original test locomotives that came here to Grove City for the U-50s. And I believe even some of the wheels, the trucks, were reused on the U-50s. The bodies of these were scrapped, and probably the engine blocks also, unless they were resold, perhaps even for some foreign markets. And I just had to put this in here. I can't even remember where I got these, or who sent them to me, or how I got them, or why this happened. Maybe Nate or Mike.
Jim Scott, if I'm not mistaken.
Jim Scott was the fellow's name? Okay. The Bessemer and Lake Erie Railroad actually had to shove one of these engines down 12th Street in Erie after it was brand new. And this kind of gives you a little bit of the size comparison of one of these. We can see a man standing here, probably the conductor or brakeman here, and the size of the switching locomotive from the Bessemer, and what we would consider today quite a boat compared to the size of one of these U-50s. Anything in these photos, locomotives or cars, would be wonderful in anyone's collection or museum. The only other railroad to purchase any one of these was the Southern Pacific. They only bought 3 of them. There were some slight variations of these. And of course, the railroaders had a nickname for these as well once they got onto their property: Baby Hueys. Now, eventually, the Union Pacific did trade in all of their turbines, except for the 2 in the museums, for the U-50s, and also for some slightly larger U-50Cs. General Electric, as time went on, was able to actually reduce the size of the engine block by 4 cylinders and increase the horsepower up to 3,300. They put 2 of them inside here, one here, flipped the radiators around under one cab, and when these were traded in, they took the wheels from them and placed them under here to create the U-50Cs. Now, these weren't quite as well liked because at the time they thought that aluminum wiring was a good thing and the way to go and reduce cost, but they overheated and they did not fare as well in the desert. Now, there's a wonderful article in which Mike Sly provided material to a gentleman who wrote this last year that has a lot more information about the Cooper-Bessemer and the way they interfaced with General Electric that was produced last year by Trains Magazine. There is a table in there listing all of the VFDL engine blocks in all of the railroads that were built from the time of the demonstrators and for foreign use. I provided one of these for the library here at the Historical Society, and so in the future, if you have an opportunity, it is available for you to come here and visit and to read. There are several articles about those types of locomotives, and it's wonderfully done, so I highly recommend that. Some of the material that I've used here today is in this particular issue. Now, the progression of that engine block continued, even in the hands of General Electric, all the way up, as we can see in varieties of locomotives, as the horsepower continued to increase. And this was not all of the different locomotives built. There were one-offs, smaller engines, larger ones, but these ones represent the increase in horsepower, all the way up until it reached 4,400 horsepower. This locomotive was at one point probably one of mine. I remember having it from time to time, where we see in 1993 it reached 4,400 horsepower. The C in this case stands for 3-axle trucks. The W in certain classes meant that it had a wide body, which are a lot more comfortable, believe you me, and a C on some of them meant that it had an alternating current traction motors. And these engines will pull a train, and they will pull and pull and pull. And I am always happy when I tend to get into one of these locomotives. We can see from this table that the progression of power from the baseline in 1960 with a U-25B all the way up until these 4,400 horsepower shows a 76% growth in horsepower on that same basic engine block that was created by the Cooper-Bessemer. It's probably even more if we were to take that design back into its inception when in the 1940s, when they were looking to build that for the Navy. So that's an incredible thing that we can say that was done here in Grove City. The design went was no longer went into production for domestic use in 2005 because of the emission standards that were placed on railroad locomotive production by the United States government. We started to see, because of the emission control standards, it was easier to actually build a new design engine block. This was then called the Generation Evolution Series, or short nicknamed the GEVO engines. This went from a Tier 1 all the way up through a Tier 4 requirements that we see today. Now, this doesn't mean that those engine blocks vanished. There were retrofit kits that went back onto existing locomotives, and this was one of my locomotives here just about a couple months ago. I just went back into the compartment while the engine was stopped at this particular location here west of Youngstown, opened up the door, looked at the engine block, and saw this tag here from the General Electric plant here in Grove City, and it says 7FDL 16 cylinder. And the engine block was remanufactured here in 2013. Now the engine itself, locomotive, was built in 1999, but it was brought up to the Tier 1 Plus compliance standards in 2013. So that engine is still running here, like I said, a couple months ago. Just about that same time, another one of these locomotives, this one is shown at Crestline. The door was left open as the other crew was climbing on board. And this one was built in 1996. It was rebuilt by Wabtec in 2014. We can see that tag, a 7FDL 16 cylinder, was rebuilt where? The Barkeyville Road plant. Okay, right there. So now there's also the FDL Advantage program. This took what they learned in the Generation Evolution engine blocks and applied it to some of the older engine blocks. Now they went a little step further. Rather than just the engine block themselves, it went to the whole locomotive when they rebuild the whole locomotive by adding computers to this, updated computers to the system. Basically the whole inside and outside gets a new paint job and so forth. And they now reclassify these as a CM44AC. It still has the 7FDL. We can see the 7FDL 16A. And now this actually has, and this is one of the wonderful things here about fighting global warming, it has a 150-ton carbon emission reduction per locomotive per year of operation, plus an increase of fuel savings above and beyond what it previously had from its tier compliances. And that's done right here in Grove City. So these FDL engines are going to continue in their use for many years to come. And that a lot of that rebuilding process is done right here in Grove City. Now some of these engines, when they're offloaded by the railroads, they may actually continue in service in their leasing program. These engines sometimes are upgraded, sometimes they don't need upgraded, and simply all they do is line out the logo, and then they put this little marking down here called GECX, and that means this is their leasing locomotives. They'll go to railroads that need maybe a little more boost in power because of an uptick in their service requirements. And then they may go back to storage that's actually done over in Lordstown at the Larry's Truck Electric facility at the Space Commerce Center over there in Lordstown, where they have, it's sort of like a junkyard, storage yard. Sometimes engines go over there and have the engine blocks shipped over to the Grove City plant from there and shipped back for replacement. So the FDL's future looks excellent at this point. It's been in production for a great many years, and there are still many markets available for it. We're going to see this thing in use for many years to come, which is a real kudos to the folks that made that original design all them years ago. And one of the things that just came to light here just in March of this past year in Railway Age magazine was that Wabtec, in conjunction with Union Pacific, is actually working on those engine blocks burning a biodiesel fuel blend out in California, which they hope to show a gas emission or greenhouse gas emission reduction of 26% by 2030 and almost a zero emission by 2050. And that's on the same engine blocks that we've been talking about. So what about those 7 FDLs that have been saved? Have any of them been saved just in case things go awry? Well, yes and no. Unfortunately, those XP24s prototypes that really made quite a landmark, let's call it, mark in the industry. Well, one of them was around the GE plant for a great many years up in Erie. And they used it they called it as a paint swatch up there at the paint shop. And as the story was told by someone to me from up there at the plant years ago, they were intending on using this as, let's call it a lawn ornament in front of the factory. And they had called in a contractor to scrap out the engine block from it. Now, I kind of think that's kind of sad because that was actually a Cooper-Bessemer engine inside of it. But maybe someone there thought, well, that's a Cooper engine, not a GE engine, let's get rid of it. But whatever their philosophy was, I can't say. But they didn't keep their eyes on them. They didn't give them quite the direction that they needed. And they cut the car body in order to get to the engine block, and they destroyed the car body, and that's what they really wanted to save. So they pretty much destroyed the whole thing in order to get to what they were looking to get at, and the whole thing was lost for posterity's sake. So unfortunately, we lost this one forever. However, there are some that are still around. And the U-25s actually, or that whole class of universal locomotives, did get a nickname. They were called U-boats by everyone and that bought them, that ran them, and so forth, and it stuck. Out of all the ones that were built in the United States, there are still 58 of them that we're keeping track of. Many of them are stored, some are still working in industrial operations, some are actually preserved in museums, and some of them are on short line railroads. And there are still a lot that are overseas, but they are hard to keep track of. And so the ones that, there are some still in domestic, in the domestic use right now and in museums. Some that you can go see that are close by with the 7 FDLs and the U-25Bs, of course, are at the Lakeshore Museum. This was the first that was built for the New York Central. And, well, I guess I should say, unfortunately, none of the ones with the Cooper engines have remained. So we don't have any of the ones with the Cooper engines. However, all of these with the 7 FDLs, these are. Now, this one is actually being used for a presentation from Operation Lifesaver. Operation Lifesaver works in conjunction with railroads and museums to help demonstrate to the public the dangers of trying to beat the train across the railroad tracks. Okay, and coming from someone who operates trains, I see this multiple times every day I go to work. All right, and it's really a sad thing. The difference between a car and a locomotive is the difference between a can of Coke and your car. If you've ever hit a full can of Coke with your car, that's exactly the difference that I feel in that locomotive. And I can't stop it. Imagine if my train is 18,000 feet long, how long it might take my train to stop. If your car is only 10, 12 feet long, imagine if your car is going 60 miles an hour and what would happen to you if you tried to stop it in 10 or 12 feet. Yeah, it would take me miles to stop that train. I can't stop if you pull in front of me. So it's a very positive thing and that they do. Now, there are other locomotives up there at that same museum that have the 7 FDLs. A couple of them have been recently provided to them. Some of them are some wonderful colors, and some of them are a little bit more on the modern side, okay? Including even this one here. that was originally built as a Union Pacific locomotive, but was returned to serve in their test fleet. And it was the first to have alternating current traction motors in it, right here. And all of these, along with that old Cooper-Bessemer center cab, is right up there at the Lakeshore Museum, along with that engine block that has the national land or the landmark dedication. Now, we think of what the Cooper-Bessemer was able to do, what a landmark engine block they were able to make there and design there. This is a brochure that many of you may have seen from an open house that was done there in 1947. And when you open up this brochure, what you see is not as much about the factory itself, but it lists 66 departments. And these are the number of people in each one of those departments by name. By name. And this doesn't reflect the directors and officers in the front of the book. These are the actual people who worked there by name. It wasn't the plant that did that. It was the people that worked there that did that. The people working together every shift of day and night. These were the people that lived here in town, the people that were your friends, neighbors, relatives, and the people that are no longer with us. These over 2,000 people worked at the plant in 1947 to produce an engine block that is going to not only here today, but are going to be here for a great many years to come. People like Melvin Helmick, who was the manager of engineering there, as we see with some other Grove City residents at a meeting here prior to his passing. So what happened here at Grove City? Did it have an impact on the rail industry? I think it was a highly significant impact on the rail industry. Something that we see every day, moving of the freight, moving of the products to the manufacturing centers, and moving of those products to the distribution centers, and what eventually ends up in your home. And what we see here happens every day. And it still happens in our community. The GE plant would not be here today if it wasn't for, and not only one, but two plants wouldn't be here today if it wasn't for what happened at that plant at Cooper-Bessemer. Not only that, but the GE and now Wabtec celebrated its 50th anniversary last year in our community, providing employment opportunities for not only our local community, but for the region, as county and region as well. So there we have it. So what started out as a little bit of an interest by this thing catching my eye when I first moved into town brought me to find out more about the first locomotives that had been built there, the test locomotives that brought about its cooperation with GE to build a landmark engine block that built the first production locomotives for General Electric, and is in every locomotive that I tend to go to work on every day to bring the freight to America. And some of the things that have been saved, some of the things we can still go see, touch, and climb aboard at the museums in the area. So I'd like to thank everyone for coming, but I'd especially like to thank all the former Cooper-Bessemer employees for what they were able to accomplish there at the plant, and the folks here at the Grove City Historical Society, Mike Schley in particular, and the good folks up the Lakeshore Railway Museum. Just like the folks at the plant there, nobody can do it all alone. The folks here at the Grove City Historical Society, nobody can do it all alone. And I couldn't have done this presentation without the work of everybody that has done work and the photography work, the research material that they've all done before me all along. Now, bringing this all to an end, I do want to do a little bit of a highlight on what's to come when we start to look back in September here in the fall series. We're going to take a look at some of the things that came about with the saving of the tender frame here with Nate Clark, my friend here. We worked together to not only in the 11th hour when they were cutting the frame up to save the tender trucks at that point, I'm going to talk a little bit about the research that was necessary to find out where it may have came from. In the process, I was introduced to a gentleman, a former Cooper-Bessemer employee, who built his own steam engine out of junk parts that I think he smuggled out of the Cooper-Bessemer plant.
No, he paid for them.
Oh, he paid for them. Okay, yeah, that's what we're going for.
And then smuggled them.
Okay, Mike and I also got a chance to go visit the Age of Steam Roundhouse in Sugar Creek, Ohio, to find out where those trucks are at. That's the mechanical engineer standing next to the trucks, where he introduced us to a movie star, a war hero, a former resident of the area, and we also found out that that's the new home of a tender from the Bessemer and Lake Erie. It's soon to be mated with the boiler section and return to steam. The largest steam locomotive to operate on the Bessemer and Lake Erie will soon return to steam down there at that particular museum. We'll be looking back here at the Cooper-Bessemer, and we'll take another look at the Whirlies, the nicknamed Whirlies. And we'll also, Nate was able to locate inside the factory the General Electric switcher inside there. We'll see how it finally was brought out into the light and put on a truck to head to its new home. Unfortunately, we all know about the traffic jams and the routes around town last year because of all the construction. Well, when that thing left town, it kind of left in a strange sort of way, right across Bessemer Avenue there, and finally ended up in Northeast along with all of the other Cooper and 7 FDLs. Okay, so we'll see that in September. I hope you all come back for that. And so I'd like to thank you very much for coming. Please stick around. We got plenty of cookies and refreshments and so forth. So thank you very much.
Are you duly amazed? And I won't give you a test. I was sitting there thinking, oh, I hope he doesn't say he's going to pass out paper and pens.
I was going to, but my wife stopped me.
Thank you, Renee.
Bob's exempt. It's his birthday. He doesn't have to take the test.
You know, the one thing that homes home to me, and maybe to you, I was raised in Grove City, born in 1945. Dad worked at the Bessemer all of his working life, core room, foundry, whatever. The hometown boy is never recognized. The hometown whatever in life is seldom recognized until someone does the quality of research that this gentleman has done.
Which you did.
Is that not true?
Thank you.
And
Yes.
I won't go religious on you, but it goes all the way back to the hometown boy not being recognized in his hometown. But needless to say, thank you.
Thank you very much. I appreciate that.
You need a hand? At 80, you're entitled, you know. You're allowed to have pusher service up the hill.
You remember that?
I thought you looked familiar.
How you been doing?
Not too bad. How about yourself? Okay. It's been a long time.
I know it.
It's been a long time.
Yeah, I will.
Yeah, I thought you looked familiar. We're discussing somewhere. Wait a minute. It's been a while. Just snuck in on me.
That was that engine.
Yes, it was.
And it was going back to the Larry Truck and Electric.
Yep.
You bought it in Newcastle.